Hi, everyone. Good morning. It's my pleasure to introduce Dr. Angeliki Lazaridou today here with us. Dr. Lazaridou received her PhD from the University of Trento, where she worked on teaching agents language in grounded environment. Since then, she has worked on many problems related to deep learning and grounded communication. This involves multi-agent, spatial learning, and several other problems related to reinforcement learning and other learning techniques when it gets to communication. And one of her goals is to make these models more natural and human-like and enable them to reason the same way that we do when we communicate and when we're learning. Without further ado, I'll pass the mic to our invited speaker, where she's going to talk about opportunities and challenges on communicating using large language models. Thank you.
Okay, so hi everyone. Can the remote, they can hear me, right? Okay, great. So yeah, I'm Angeliki. I work at DeepMind for the past 5 years, and this is my first keynote. So you will know actually. I want to. So I've been doing mainly research on multi-agent communication from the very last bit of my PhD and then through the first years at DeepMind. But recently, I was really taken aback by the new era of large language modeling. The new generation of models are okay. So anyway, I was taken aback, and the new generation of models are really exhibiting some amazing capabilities. They have diverse, like versatile skills, a number of like different applications use language models either for communicating or for all sorts of like assistive applications, even chatbots. Creating websites, writing, I don't know, pieces of text, really, really amazing things. However, they also exhibit a number of challenges, and I think some of those challenges, they might become an obstacle towards using these models in the context of applications or communicating with humans. So I want to take some time and talk about some of these things that I think the community has identified. But before I get into that, I'd like to, in the context of being Thursday today, like give a bit of a throwback and start this talk by saying that. So when I was a PhD student, I was really interested in language learning. However, I was a bit dissatisfied by the fact that language learning in the context in particular of NLP was mostly boiled down to just structural learning in the majority of the case. So basically taking a data set and then doing some supervising learning on it. And when thinking about communication and what does it mean to communicate, I realized that there was like a very big disconnect between how we or how and why we as humans we use language. And I don't think I can pull this quote on my own, so I'm attributing this to Wittgenstein, but basically a big chunk of the language, if not the most important one, but let's like leave that as a footnote, is the functional aspect, the fact that we are using words to make things in the real world and through interaction with people. And this can be, like simple interactions, like, asking someone, to pass us a book, or using language for more complicated interaction, problem solving in groups. So then I was interested in trying basically to unify these two types of learning to maybe, you know, think about a different way that we can operationalize language learning. And when thinking about this, then this cute picture came in mind, which is basically that potentially if we want to do language learning, then maybe we should try to simulate this interaction, but with our models. So I was working essentially with a framework borrowed from multi-agent learning, in which we have two agents, both of them operationalized, parameterized by neural networks. And then these agents are placed in some environments, grounded environments, and they need to solve a cooperative task. And then in order for them to solve a cooperative task in the same way that humans in the other picture, you know, how to like coordinate to pass salt to one another, then these agents would then emerge some sort of communication so that they can achieve their common task. And you know that this is emergent communication because it's not like at this point, it's not like natural language, it's some induced protocol. I'm not going to get too much into this, but this is like a very rich area of research currently in the community, and there is like a lot of great work happening. So yeah, just I have a pointer if you want to, yeah, I have a pointer to a paper that has pointers actually. Anyway, but the dream then, having this framework, was that the agent's language, despite the fact that they are not natural language, because they are learned in this interactive, communicative setup, which mirrors a bit how we as humans learn language in these interactive setups, then the hypothesis was that despite the fact that this wasn't language, natural language, mapping it to that there will be a correspondence with natural language. So concepts, important concepts would have emerged. And so the dream was that then learning this mapping would just be, you know, just a piece of cake, like with a bit of data, then we can just induce this almost linear mapping, which, I mean, it's an oversimplification, but I think you get the main point. It's never linear. Okay. So this is basically the dream, but there is a different perspective here, though, which is, I think, equally important. The alternative perspective is that we can actually see multi-agent communication as an unsupervised learning setup for language. And this is an interesting perspective because then it allows us to bring into this type of unsupervised learning a lot of biases. I mean, every unsupervised learning means biases to pan out, and seeing that as a communication task that allows us to bring biases that have to do with language, for example, the principle of least effort or Grecian maxims, and hence have a better chance of emerging something that might actually be alignable to natural language. Okay. At this point, you might be wondering, okay, why am I talking about emergent communication when the title has language models? The main reason for that is because starting from this framework of the emergent communication, if combined with occasional natural language in the mix, so adding basically a bit of natural language supervision and a bit of natural language exposure, then this paradigm, this framework then really becomes a self-play that facilitates communication-inspired data augmentation, just like an alternative view. And I mean, who doesn't love getting more data here? No, but I mean, seriously, like we are 2022, we have big models, we have a lot of data. Should we care about getting more data, or why should we care about getting more data? I think it's the better question. In fact, according to the Kaplan et al. Scaling laws of very big language models, the model is actually, the bottleneck is actually not in the data, it's in the hardware of training big models. Because, as they write in the paper, and I quote it here, big models may be more important than big data. So according to this, we actually, we don't need to care about getting more data, getting better data. All we need to care about is getting big models and bigger models, and maybe ultra big models. However, that's very far from reality. 2 years later, the Chinchilla language model, worked by colleagues at DeepMind, offered a very attractive and interesting, actually, plot twist. Chinchilla is a language model. I mean, it's still a very large language model, right? I'm not calling it a small language model. It's a very large language model. It's a 70 billion parameter language model, but is significantly smaller than the biggest language models out there. However, this language model is trained on significantly more data. So it might be 5 times smaller in size, but is trained in 5 times more training data, to be specific, in 1.4 trillion tokens. So not only smaller, but trained on more data, but like the most important, exciting finding is that this actually works. Like, you can make if you have good and a lot of data, then you can afford to make your model smaller. And as the authors have found, I'm not, discussing all the results here, but please, feel free to review their paper. This model is actually better. It performs, in some cases, quite significantly better than the largest language models. So this is an interesting, it's an interesting spin, and it makes us now think of, we had 1.4 trillion data, but what Chinchilla basically says, and the implications, is that it indicates that really the bottleneck is not building bigger models, but getting access to higher quality data. And this is something that, should perhaps, if not, like, should perhaps basically get into our discourse, how to do better at getting those data. Now, note that this implication is actually even more significant if we want to have even smaller data, because we can, we can do the trade-off between, if we had way more data than 1.4, maybe we could make our models even smaller. And then, we are starting talking business here. Like, imagine if you can have like a 10 billion model, or a 5 billion model, or a 1 billion model. I mean, these things can, can run on actually GPUs. There is like a very, it can run on GPUs, right? Oh, sorry, I thought you were, I thought you were commenting. If you're interested on this topic, like, I'm quoting like a very insightful blog post that articulates a lot of these implications. But anyway, the question is, do we have enough data? To be fair, I don't know. I tried to make my best effort in trying to collect all the available data, publicly available data that are out there. I found this. I mean, of course, there are a few more, but it's not like there are like 5 slides more of this data. It seems that we are a bit, we don't have an abundance of data, general data. And when we think about task-specific data, then this number reduces significantly. So what this means here is basically that potentially we need to start thinking about creative ways for us to start, bootstrapping our data, generating our data potentially as an answer. creating data or like, bootstrapping existing data might actually be a good bet to take now, because our language models are actually, getting better and better at generating like their quality. I'm not talking about coherence and all these things with groundedness, which is like a big problem, but like generating like text that, in some context looks okay is, we can do that today. Okay, so maybe we should start be thinking about creative data generation. Okay. There are actually we have started already seeing a few avenues on this, and I'm going to breeze through like 3 case studies that might spark some I don't know. I mean, I'll be interested later to know your thoughts actually. So the first case study looks into generating question answer pairs, for example, to be used for like fine-tuning question answering systems. In this work, Lewis and colleagues, they created a repository of 65 million, as they call it, probably asked questions. And their setup is conceptually, like pretty clear, simple. They start from Wikipedia. They identify passages that can lend themselves to generate interesting questions. They identify answers that could be potential answers, like named entities, dates, well, named entities and dates actually. And then they create a supervised problem out of it. So now they have an answer. Sorry, they have an answer and they have a passage. The task is generate a question. They fit a model on existing QA tasks, then they unleash it on Wikipedia, and then they get a gazillion questions out. Now, on the right, I have some examples from the paper. As we can see, the questions, I mean, they're factual, short questions. They're not too bad. One problem with this framework is that, like, of course, it does not guarantee, the correctness, the factuality of the question. So a very important step here is to do, as they call it, global filtering, like basically filter out any sort of questions, like the last 2 questions that kind of like don't make sense. In a similar spirit, Liska et al. Used a question generation, a similar framework, but in this case using few-shot prompting, but not supervised learning to generate the questions, as a way to generate questions grounded at different points in time. And that allowed them then to study problems like, keeping models up to date. Looking at the studies, one thing that will be extremely interesting is to see whether, we are able to get potentially, more challenging questions, multi-hop questions, reasoning questions. The raw material is there. We can do better than this, but there is already like some solid ground. The second case study, it's about generating dialogues. Now, unlike it's a work by Dia colleagues, they start with so their take is that, it builds on the hypothesis that training supervised models on a lot of data is a sensible path. And in this way, they're able to generate, 19 million dialogues. And this might be, particularly interesting when you want to generate data in a domain where you just have, documents, like you don't have like task-specific data, just, general text. Their assumptions, their observation here is that any text has some communicative intent, in the sense that every single sentence that exists in the document is the writer's answers to a reader. I'm not sure how deeply they thought about it, but this is actually like a pretty interesting insight, like on different ways to think about, you know, static like documents. And so their approach here works, you know, then in a similar way as question generation, but it's contextualized within a particular text. They see the sentences as answers to questions, then they fit a model to generate questions, but at the same time, the model that they fit to generate questions also takes into account the whole context so that it's more natural dialogue. The last way to, the last case study that I want to briefly discuss is, you know, turning back to the beginning of the talk, to using self-play as a way to turn general language models into task conditional language models. So what this means is that we get access to a language model, a pre-trained language model, and what we want to do is to turn that conditional to a task conditional, and we are going to do this by generating rewards through self-play and then updating the language model such that to induce this conditioning. I didn't put the citation here. This is a work I did with colleagues. I hope people are not tweeting my talk. I'm sorry. Yeah, okay. This is a work I did with colleagues at DeepMind, and in this particular instantiation, our general language model was an image captioning model. And all we wanted to do is turn the image captioning model into a discriminative image captioning model. And the question was how to do this merely through rewards and self-play without having access to any task-specific supervised data that would allow us to do supervised learning. The thought we had is that to do reward, well, the thought we had to do self-play, the first thing that we need to get out of the way is we need to create some RL environment. So in this case, we took the referential game and we turned it into an RL game. So we have a target, we have a distractor, and we have our two agents, the speaker that also has a pre-trained language model, the pre-trained language model that can do captioning but not discriminative image captioning, and the listener And the task is for the speaker to communicate something about the target such that the listener picks the right target. Now, many things appeared in the screen. This basically defines how the whole environment looks like. So our speaker is the primary learner, but the learner that we actually care about, you know, having at the end of this learning business. The listener here is going to act as the scaffolding learner. So the learner that is going to help us bootstrap the speaker. The action that we need, because this is an RL environment after all, is the caption that the speaker generates to be passed on into the listener. The state that the speaker and the listener get are the two images. Now, the learning signal for the speaker comes from the reward that the listener creates by taking the action and then deciding which of these two images is the right one. And if the listener is right, then there will be the equivalent reward. Okay, so these are all nice. You know, I showed ideas, I didn't show any results. Like things work, you know, kind of, sometimes a bit better, sometimes a bit worse. But there are like a number of gotchas when we talk about bootstrapping data. First and foremost, we should, you know, these are not natural data in the sense that data generated by humans. These are model generated data. So we should consider the acceptable signal to noise ratio that we feel comfortable with. Depending, of course, on the application. In particular, if we want to use, this type of methodologies for creating data for applications that are then, are put in front of humans, maybe for communication, maybe for something else, there is a lingering concern about generating, non-factual things, which are then, amplified further by the model through the bootstrapping phase. And as I mentioned, in both of the papers in the studies in the question generation setup, there was a very, very aggressive filtering, sometimes even involving human annotation to eliminate things that just, are nonsensical. The second, it's a gotcha. I think it's a gotcha and a trap. It's that sometimes when we are in the context of bootstrapping, multi-agent communication, bootstrapping, data generation, it's very easy to just get. I use the word trap again, and I'll use it again. Trapped in this mindset of training, splitting our data that we generated into training and test, and testing how well we generate the test data, which is great. We should absolutely do this as a sanity check, but this should by no means be like the final evaluation that we report. All of the ultimate goal of the data generation and bootstrapping is, and multi-agent communication for that matter, at least in how I view it, is not the end, is the means to an end, like the means to have better data, to be able to have better communications with humans or better performance in tasks. So extrinsic downstream evaluation should always be there, either with a human performance or at least some automatic data set on data curated by humans. Another thing which is a bit more specific to the third way of thinking about creating data, which is the self-play, is that when we do self-play in multi-agent frameworks, even if we have natural language in the mix, language can, and I guarantee that it will drift. And when we talk about language drifting, we mean having language being generated that does not comply with our grammar, with the grammar that we as humans are following, does not comply with the semantics. So, words are used in the ways that they shouldn't be used, and pragmatics, which is like a bit of more of a nuance aspect. So something to keep track and monitor and alleviate. Last but not least, I think there is the mentality that data, they don't have an expiration date, that we have some data and then we can keep using the data for the years to come. Unfortunately, data, both real and generated, they will get outdated in the sense that we will reach a point that training on this data is actually harming the models than, no, not harming the models, harming our applications if we train on this data. And I want to discuss a bit more this aspect and explain a bit more what I mean. It's the reason why data get outdated primarily is because language is evolving, the world is evolving, and language is evolving. And the fascinating thing here is that there are different time scales into the different aspects of language that get outdated. Of course, we have grammar, and hopefully, fortunately for us, grammar does not really evolve, does not really change significantly very fast. So maybe it's something that takes centuries or maybe decades for some maybe syntactic constructions to appear. I wouldn't say that this is like the major thing we should be thinking about, but it might hit us at some point. So yeah. Now contrast grammar with lexicon. Lexicon is one of those things that that has like a much faster pace. So we have words appearing in our vocabulary very often. COVID, for example. COVID was not a thing in our vocabulary, but after 2020, it appears in our everyday communication. So this will actually cause problems to the model, primarily also because of the way that we represent tokens in our language models. Yeah, through BPs and all this. The other thing that gets outdated is knowledge, and here knowledge is actually one of those things that can start getting outdated, even with a meaning. Like, for example, look at stock market, the weather, especially in Edinburgh. Like it can change from like one day to another, and so it becomes super important to not assume here that knowledge doesn't change. Finally, something that is somewhat, I believe, underexplored in the context of NLP and models is the speed of change of conventions and social views. And Emily Bender and colleagues in their stochastic parrots, they have an excellent discussion on this. They give as an example the BLM movement and how this has changed the discourse in the society, and then in the Wikipedia, which is one of the, the bread and butter of language models, basically. So yeah, it's important that our models also reflect the up-to-date views that people have with respect to the world. But like another slightly interesting aspect, especially when we care about language models for communication, is that it's not just that the language so an evolving world does not just change how we talk about things, it actually changes what we talk about and the type of things that people are interested in knowing when they interact with our applications. 2019, in the US, great year. People care about Disney Plus, iPhone 11. I mean, of course, some other things happened, but contrast this with like 2020, which is like a year we I'm speechless. Anyway, you get the point. Election results, coronavirus update, Zoom. Okay, again, PlayStation 5, but it's like completely different. So we need to take this into account when we build user-facing applications, or when we create user-facing tasks. The bad news here is that this is not just a hypothetical problem that we can be chatting about. This is like a real problem, and our models, no matter how big they are not yet fortune tellers. Like they cannot, with accuracy, predict what is going to happen. Even we cannot predict. Of course, we can anticipate some things, but many things, we can't just predict. Concretely here, we showed that performance degrades if we keep a model stale even of up to 2 years. We see 50% worse perplexity, especially on knowledge-intensive tokens. Why? Because, as we said, knowledge involves with a meaning. So, okay, what do we do? First of all, we need to talk about benchmarks, which is the start of every discussion. And the past, especially the past years, we've seen a lot of temporal benchmarks appearing in the context of pure language modeling research, question answering data sets. Of course, name entity recognition and some of these tasks are, people were more aware about these temporal effects in these tasks. Yeah, and it's interesting to think about how a temporal data set of dialogue would look like. Maybe something like this exists. Yes, I'll be very interested to know because I find it fascinating research. Okay, so we have data. The next question is then how do we keep our models up to date? And there are different ways to do here. One thing that we need to consider are the memory versus compute requirements. Memory requirement is how many things basically we need to store to be able to do what we want to do. Compute requirement is roughly how often we need to touch our model. For example, fine-tuning a model is way more compute intensive. Retrieval models are a very, very appealing way to keep models up to date because there are no model updates required, because we can just put all the new data available in the search index, and offer as a byproduct also a way to alleviate hallucinations, which again, it's something that, because we can ground basically data on evidence. On the other hand, of course, because the search index increases, like at some point we're going to have just too many things lying around, so that might be a bit of a problem. But I think like an interesting challenge here is that if we have a language model that has some views, we don't touch it, and then we just have new data in the search index, there will be a point where there will be contradiction between what the language model thinks and what the search index thinks. And then, it's not clear who to trust and what should happen. Another way to keep models updated is to basically keep fine-tuning the language models on the new data. And this is great because, first of all, we don't have anymore the contradiction issue that we had before, because all the model has everything it needs to have in its weights. The problem is that there is a lot of redundancy found on text, so we might be keeping, spending compute, teaching the model the same things that it has already known. However, the biggest here drawback is that keep fine-tuning models, basically touching weights, it's a very tough thing to do, especially when parameters of models grow to billions. Of course, there are good alternatives here like adapters, but it's something to keep in mind, this trade-off here. A relatively new, recently proposed way to, that in my mind stands between those two, to keep models updated is the so-called knowledge editing. And in knowledge editing, basically, we surgically update the parts of the model with knowledge, particular knowledge that needs to be updated. So in theory, this combines the best of both worlds, which is great. However, in practice, existing work is only able to update only a handful of parts. So this is like it's a new topic coming up, and it will be great to be able to do this knowledge editing at scale. So what we see here is that actually the discourse around static models and data is changing very rapidly. And like as an example, Hugging Face has recently committed to be releasing masked and causal language models that are trained on updated data. Why? Because so many people use today models in their applications that were trained 3 years ago, and the models that were not even aware of COVID. I mean, this is just one example, but basically using models that have no touch with reality, with today's reality. Despite all these challenges that we might be seeing in these models, the new generation of models are still really exciting. And I think that they might even be more exciting than we currently think. The reason why I'm saying this is that a lot of evaluation benchmarks that we have today were actually created where many of these models were at random in many capabilities. And here I'm just giving an example of 4 tasks from the Emerging Abilities of Large Language Models paper, where they plot performance on some tasks across different model sizes. And the authors report that a large model size is when some capabilities emerge. So basically,
it's not really unthinkable that some of the capabilities that we might have some of the capabilities that we might care, they might have already emerged, but we still haven't found them. An interesting observation here is that Twitter evaluation, I mean, it's a bit funny, but Twitter evaluation is a nice complement actually to quantitative benchmarks, because often we see people, poking the models in different ways and finding out, new capabilities and interesting insights that our static, benchmarks cannot necessarily, convey in a reductionist number, 42 performance. So perhaps, we might be in need for a new usage-based evaluation framework. So not just human evaluation, but usage-based, basically, maybe humans using models to do something, blah, blah. I'm not sure. I don't have the answer. It's just like just a feeling. One capability that has emerged very recently, and I find extremely exciting, is the modular nature of these models. End-to-end learning has taken over the field of NLP. I think dialogue systems perhaps might be the interesting use case where modularity is there, has been there, and will be there for a good reason. But for the rest of NLP, I think everybody bought the end-to-end business. But modularity is making a strong comeback, and is opening up to the road to exciting new problems. Of course, modularity. What do I mean by modularity? We had composition of weights before, right? I mean, this is the classic transfer learning where we take word to vec and we put it into a system, or we take BERT and we put a classifier, So pre-trained weights have been used to initialize parts of bigger networks, and this is like a very, very good approach to have like a head start in our application. So this is not new. This we know. The new thing, though, or the newest thing that we now start to see is the type of probabilistic inference where a complex task is modeled as a function of simpler subtasks for which we have pre-trained models. And in particular, when this happens through language via prompting without required training to perform the new downstream multimodal tasks. So just to make it more concrete, this is one particular example from the Socratic models. And here, the authors, basically, their assumption is that each model can be seen as a black box queryable API. And so if we have this view, then what we can do is that models can get stitched together by piping a model's output to be another model's input, and then using few-shot prompting to blend the two. In this particular example, the authors took web search, they took a language model, and then they took a vision model, and they plugged these things together to create a multimodal assistive dialogue model. Related ideas are currently being explored as well in the community, for example, around making use of search engines together with language models, or using the idea of scratch pads together with language models to facilitate more reasoning-like process in the models. I mean, the fact that we actually need to do those things, it's an opportunity, but at the same time, I would say it's a challenge of the current models. But anyway, take it as you want. It's exciting. It's exciting anyway. Okay, to start basically summing up, I don't know, breezed through different aspects of language models that I find exciting, that in some cases relate to communication or using communication for language models. spinning things around from multi-agent to language models to discuss some of the challenges, but also opportunities that that we see that excite the community, and we see a lot of work. The new generation of models are very powerful, perhaps more than we can think for the reason I just discussed. This might mean that we might need to revisit evaluation practices that allow us to better grasp their capability. So create evaluations for the current generation of models rather than only continue having the same evaluation practices that were developed when models were of different performance, so to speak. A new emerging capability is their increased modularity. This is extremely exciting because we can shift mindset, and instead of thinking about monolithic generalists, we can work towards generalists composed of specialists. Increasing the capabilities of models might require us getting more data, especially if we want to have smaller models. Data will become our bottleneck, so we might need to get creative and perhaps start generating those data, bootstrapping the data. And finally, we often assume, as I said, that data do not have an expiration date, but sadly, I hope that I conveyed that data do expire. Missing out on new opportunity, on new information would definitely negatively impact our models, and it will do so in multiple ways. And so it's important to start thinking about ways to do this efficiently and at scale. And I think with this, I'll call it an end.
Hello. Oh, sorry. For the people online, this is Oliver Lemon from Heriot-Watt University. So first of all, thank you for that talk. I really enjoyed it. I find it really insightful and very exciting. So thank you very much. My question goes back to the work on kind of emergent communication about images, and I find that very, very interesting in general. But what I noticed was that the listener only kind of gets to choose one of the images. They never really get to say anything back to the speaker. So they, for example, they can't ask a clarification question or something like that. So my question to you is, has anyone worked on that idea in emergent communication? And do you think it would be useful that the listener could actually have a dialogue more with the speaker?
Yeah, I mean, that's a great question, a lingering concern. I think like in these simulations we have with emergent communication. In general, when we want to use emergent communication as a vehicle for language learning, it's important to have that being as close to the actual human interaction as possible. So it's definitely, I mean, you're absolutely right. This particular type of interaction is currently very limited, and the result of that will be that whatever communication is getting shaped is going to be not at full scale, so to speak, of what could be done. It's a lot of emergent communication work actually has focused on this particular setup. However, there have been cases where studies try to do emergent communication within a dialogue. So you have basically every model
doesn't have just a single function of generating, but has this dual model of both generating, but also acting as a listener. Still, from what I see, my humble opinion is that it hasn't really so much taken up. We haven't given it the importance that it should get. And towards making, closing a bit the gap between the multi-agent simulations and the realistic, so to speak, simulations, this is one of the things that we should be doing a bit more. There is some work, but not as much. Basically, is the answer.
Okay, thank you. Yeah, I'll follow up offline. Thanks very much.
Thank you. Great talk. I wrote down a lot of notes and have a lot to think about now. Not that we didn't have a lot to think about before. I have a lot of questions for you, but one that I would like to ask is what is your end game here? Because you took us on a tour of all kinds of things. And to me, I can pick out some ways that they're related to each other and kind of what you're driving at. But really, what is it that you as a researcher with your kind of long-term goals, what are you driving at? And not just with language models, but like those are a means to an end for what you're working towards. What's your goal?
Without having had coffee is
If you're not ready to answer that, then I can.
No, it's what's my goal? Like I started with the goal of doing language learning, and that was something I was very excited about, and that's where I thought, okay, multi-agent communication. Back then, I thought multi-agent communication could help us, move the needle on that. In the process, large language models came out. GPT-2, I think not that many people believed, but with GPT-3 and these models, this was something that made me. I thought it's a milestone that the community has hit, and I ought to take a step back and revisit my goals. So then I tried basically to contextualize the multi-agent communication with the large language models, and how I felt that there is a path there is, first of all, to understand the type of things that language models cannot learn currently. I use language models, like they can be grounded language models, audio language models, but I use the same family, like language models, that they can't just learn from data. And I'm still actually trying to answer, for example, we tend to think that models that are not good at compositionality, or like they don't form compositional concepts. But for example, when I look at all the recent advances on, especially on the image models, because perhaps there we can talk about compositional concepts in a more grounded way. I'm actually pretty astonished by the amount of compositionality we see. Again, is this on the data? Is this emergent? Like, is it? These are still questions that I would like to get an answer, but basically I'm revisiting a lot of the things that I used to think, because I feel that this is a new generation, and I'm trying to understand what is the common denominator that can continue or that can change. But the main thing that I see as a goal here is the notion of being able to keep our models up to date, which is perhaps of a meta goal. Either, basically make models aware of the right here, right now. And this might seem like maybe, an easy goal, but on the other hand, it's actually not easy, especially when we do it at scale. We have like a lot of problems making models aware of the right here, right now, without also forgetting the past, because this is like a very delicate balance. And then all these questions then sort of blow up in complexity when we think about keeping not just
text-only models up to date, but also, vision models up to date and video models up to date. So to sum up, I'm trying to bring some of the multimodal research that I was doing to the current era, and try to think about ways to keep models up to date, but also very much concretely, one of my goals is also to be able to have ways to really understand what models can do, which is not so much about communication, but maybe here communication might allow us actually to get a better answer, because we can try maybe to see communication as people communicating with models, or maybe models communicating with models, as a way to have more interactive evaluations. An interesting, I mean, maybe I should have talked also about this, but like an interesting aspect here of interactive poking to understand is recent work, for example, on red teaming, where it's kind of like adversarial learning, where you have a model and then you have another model that tries to basically find all the edge cases. And this can be something, for example, that can be used for mitigating safety, unintended behaviors. So that's basically the other thing, using communication to understand the models. Yeah, anyway.
Hello. Gabriel Skanse from KTH here. Thank you very much. Very interesting talk. I had a more specific question about this dialogue in painting work that you did.
It's not my research.
Okay, yeah. Anyway, so you take this sort of monologue text and turn it into dialogue, but in monologue you have sort of these full sentences, but in a dialogue, people don't often speak in full sentences, but they use ellipses and so on. What's that something that you or your colleagues were looking at, how you would actually achieve something that looks more like a real dialogue?
Yeah, so this is a great question. These are not my colleagues. It's just I don't want people to think that all these things were my work. Like some of these things were my work, but some of the things I don't have over, it's just like papers from the community that I thought would be like, would convey some interesting message. Closing the parentheses. You're absolutely right. So I looked at some of the examples that they had, but it's so the generated dialogues, they are very clean, like maybe the what is the like clean in the sense of like all the questions make sense, we don't use like we are very explicit with what we want to say, which is, yeah, as you said, like very far from the actual communication that is happening. And link like an issue, well, I think one of the things that would be great to see, but we didn't see it from this paper, and this was also my implicit comment, is what happens when we take this generated data, we train a model, and then we apply it on actual, language, like do dialogue basically on actual, dialogue data sets, because that would reveal some of these issues. I guess there are like different ways to go about here, but potentially having ways to noisify, or maybe not even use Wikipedia that doesn't have things like and all misspellings, all these things are getting caught by like in different editions. So yeah, maybe looking into forums and turning those into dialogue, or bootstrapping from forums to generate new, but it's just some thoughts, but you're absolutely right.
Yeah, David Traum from USC. Thanks very much for the talk. I think it's very illuminating. I particularly like the part warning about that more data isn't always better data, and their limits, and I guess one additional caveat I'd put is that even a human annotated data set may not even be appropriate depending on the thing you want to evaluate for dialogue. But more generally, it seems like there two kinds of tasks that you're doing with this data. So for exploring the limits of the model and the uncertain area, it seems like this data generation, self-play, adversarial kinds of work where you're generating data is useful for how would I answer if I got that question. But then going back to your first slide, I think with Wittgenstein, you know, and language use, it's, you know, if I get it in a different context than I was anticipating, maybe I wouldn't answer that way. And how do you try to evaluate when you've saturated with enough simulated data and how to balance the human data that's more valuable than the simulated data?
Yeah. So we've seen in my own work, we've seen a lot of this type of drift, basically, where you called it saturate, I call it drift, but basically we see that at some point we learn some things, but keep using this data just puts the model in some space where we don't want it to be. I guess there are different ways that one could go about here, using natural language data in a better way as regularizers in addition to the generated data, and potentially, like, you know, dreaming is for free. I used to say, like, I mean, I tend to say so. If we are able to put the human into the data generation, the documentation, the bootstrapping in some way, so that, you know, we have the feedback earlier in the process, and then we are bootstrapping not just based on what the model shapes, but also what the human shapes, basically human in the loop data creation. Something like this maybe could offer a solution or some mitigation.
All right, let's have our speaker.